we have to determine the H, convective heat transfer coefficient, ourselves. Okay, to determine that, one property or non-dimensionless property names Nusselt number, this one, is used. Okay, this Nusselt number will be used to help us to find H. Okay, so Nusselt number, kalau you lihat this, it is defined as convective heat transfer coefficient times characteristic length divide by K. So saya nak tanya, K ni which K? What K? The solid medium K or the fluid K? No, not solid. Because we are determining H.
Yes.
H is fluid, right? So K also is K of the fluid. Fluid also has K values. Okay? Meaning that sometimes macam minyak ke oil or gas, sometimes it is a good conductor of heat transfer. Yeah, sometimes it is not. Like air. Air, we can use it as an insulator. Okay, the K value is quite very, very small, 0.0 something. Okay, meaning that we can use that as an insulator. That is why sometimes kalau ada rumah-rumah kan, you know, macam like overseas that has 4 seasons apa ni, weather kan. So during winter, sometimes the insulator dia macam ada buat air gap tau. Okay, the window and then ada air and then ada glasses. The air is used as an insulator so that the heat from the inside cannot apa ni, lost to the outside air. Okay, faham So okay, now this all about fluid. Yeah, no more solid. Okay, these are all about fluid because we are considering convection. When we are talking about convection, okay, convection is what? Surface phenomenon. Betul tak? Ingat lagi? So surface and also the adjacent fluid. That is why saya beritahu tadi, this is all about fluid, gases, everything adjacent to the surface. Okay, setakat ni understand or not?
Setakat ni understand, Doktor.
Alright, easy je kan? So you have to find H using Nusselt number equation. Okay, to do that, saya ulang balik. Before knowing H, we must determine Nusselt number. Okay, now I will help you how to determine the Nusselt number. But before that, okay, sometimes you have to refer certain tables kan to find out the properties of the medium ataupun fluid. Betul tak? Okay, saya bagi as contoh this is mana table. This is the table. This is the table. So you maybe want to find the mana this kinematic viscosity. Maybe you want to find Prandtl number. Maybe you want to find density. So can you see that the reference value is temperature? If you don't have the reference value, nak cari yang mana satu, which one to be selected, betul tak? So we in this chapter we will use film temperature as our reference value to find our fluid properties ataupun thermal properties of our fluid. Okay, so what is fluid temperature? Fluid temperature, okay, saya draw. This is your surface, okay, and then this is the temperature of the surface, Ts, and then adjacent to it is the liquid or fluid temperature. So let's say the surface temperature is higher lah, so jadi maybe this is how the heat transfer rate ataupun temperature distribution looks like, dia punya profile. So fluid temperature is the average values of both surface and fluid temperature. Okay, so this temperature will be used as a reference for you to find thermal properties of any fluids lah, seperti yang I show here. Maybe this, okay, 35 degrees C. Maybe, okay, this is the fluid temperature of your problems lah, yeah. Okay, boleh. Hopefully all of you understand about that. So, and then, oh, sorry. Now, after you determining the H, straight away you can calculate your Q. Itu maksud dia tadi. So now, but before we determine the Nusselt number, first of all we must, okay, identify or determine the air flow type ataupun the fluid flow type of our system lah ataupun problems. You all dah belajar fluid, right? All of you have studied fluid mechanics.
Yeah.
Okay, semua lulus lah. Tak ada yang gagal kan?
InsyaAllah.
Okay, bukan insyaAllah. Alhamdulillah. InsyaAllah belum lagi. Alhamdulillah. You done it. Apa ni? Excellently. Okay, Alhamdulillah. Okay. Okay. Tadi siapa jawab? Muhaimin ke lah ni? Dah lupa nama Alah, itulah jahat dia kan? Dia saja sebab dia tahu dia nakal lah. Girl, cubit sebab jauh. Okay, now. I hope all of you are familiar with lamina and turbulent. Familiar kan? Sebab you have passed your fluid mechanics excellently. So I think alah, ini kacang goreng je kan? It's very easy peasy kan? So lamina or turbulent. You must first determine whether the flow is lamina or turbulent. Because different Nusselt number equations different flow types will give different Nusselt number equation. So you must first determine whether the flow is lamina or turbulent. Okay, this from this figure, if you can see this figure, this is a flat plate, flat plate, and then the velocity, the flow of the fluid, this one is dia panggil apa? The V, dia selalu panggil free. Okay, I want to use the term that this book used, Okay, so sekejap dia panggil average, dia panggil free stream velocity I think. Tak apa, ada tak kat sini? Saya tak nampak lagi, tak apa. So okay, this is the free stream velocity dia tak too far from the surface of the plate. And then we also given ataupun we must know the temperature of the flow, the fluid flow. And then if you see here, the plate length, we always define it as L ataupun denote it as L. Okay. So now can you see yang ni? XCR. XCR adalah X critical. What it means? What does it mean? Yeah. So X critical ni meaning that from X equal 0 to X equal X critical, between this the flow is lamina. Beyond this the flow is turbulent. Okay. How to determine it? What is the formula of okay, saya belum cerita pasal Reynolds number. So to determine it is by using Reynolds number. So what is the formula of Reynolds number? Okay, Reynolds number we denote it as RE kan? Tak ingat. Okay. First, velocity, correct? And then? L. Then?
Over D, Dr.
D pun boleh. Kenapa dia jadi macam tu? D pun boleh. Tetapi L. Kalau dia flat plate, kita guna L. Kalau dia cylinder or sphere, we use? Diameter kan. Okay. Because you remember tak? Mungkin during fluid mechanics, most of your system adalah pipe. Right? So you usually see D lah diameter. Okay. For our case, sometimes we use flat plate. So the D we replace it with L. And then this one new. Remember tak what is new?
Yeah.
Kat sini ada kan?
Viscosity.
We have
Kinematic
two.
viscosity.
Kinematic or dynamic. But in our
Dynamic.
case, yes, we use
Dynamic.
kinematic viscosity. Okay, so we will use this equation to determine Reynolds number. Because, okay, saya keluar di sini. Saya tak nak tengok ni lagi. Okay, nanti dulu. Okay, Reynolds number. Can you see this? We have two types of Reynolds number. Okay, we have two types of Reynolds number. Okay, katalah let's say I want to know this flat plate. Okay, saya pergi ke muka surat. Saya suka pakai warna hitam tau, Siti. So, warna hitam tu dia macam menawan kan? Okay, let's say. Okay, good. So, this is your flat plate. Saya buat macam tu kan? And then, this is where X equals 0. Okay, let's say this is X equal L. Let's say I want to know the Reynolds number at this particular point. X equal, I don't know lah, adalah apa-apa value lah kan? Betul X equal, apa nak letak Okay. Saya pun tak tahu nak pakai perkataan apa. Apa waktu tu?
L/2.
L over 2. Pandai. Okay, L over 2. Okay lah, saya follow. Okay, now, kalau tadi, if you see the Reynolds number formula is velocity L over mu. Can you see that this is the L ni adalah for the entire plate, correct? But I want to study at this particular location. I don't want to know about L. So we change L to what? X. And we denote it as REX, meaning that we want to know the local Reynolds number, not the average Reynolds number. Sebab tu if you see in this, can you see this? Okay, this one is local ataupun we call it as local. Sebenarnya saya selalu panggil local Reynolds number. If this is the X, okay. So I hope all of you know mu apa dia punya equation to determine mu. We have you tak ingat fluid mechanics kan? Mu is actually equal to betul tak?
Betul.
Oh, dah tunjuk macam tu betul Amboi, lambat betul nak jawab betulnya. Okay, now this one for any distant X. We usually call it as local. So let's say I want to know at certain position. So we will use this Reynolds number equation. But for average, for the entire plate, we use this equation. Nampak tak the difference of expressing it REX dengan REL, yeah? And then the critical value, so this is the critical point, right? To differentiate between laminar and turbulent, okay? So this is the condition for laminar. Okay, it must be the R must be lower than, okay, so that is laminar. So if turbulent, it is the value from dependent surface roughness, okay. Okay, this is still laminar, yeah, laminar. These are also laminar. Warna putih. Okay. Okay, what about turbulent? Okay, now remember, katalah you calculate, you find out your Reynolds number is less than 5 times 10 to the power of 5. Okay, that is laminar. So turbulent, okay, for turbulent, itulah sebenarnya this kan is a continuity from chapter 6 tau. So for turbulent, nanti kejap. Okay. Sekarang saya patah balik. Saya tak nak you get confused. Setakat ini faham tak? Setakat ini. Okay. You have a plate. Faham ke tak? Faham lah kira kan? This is the plate. So this is your plate, tapi kenapa warna merah plate ni? Tak apalah, terlupa nak tukar dia punya ni. Wait, saya padam balik sebab dia tak straight. Okay, this is your plate. Okay. Your plate usually has two conditions. The first one, either, saya pakai warna lain. Sekejap ya, saya betulkan balik. Either the surface temperature is constant, or another one, the apa ni QS? This is surface This is surface and we denote it as S. Okay, QS, what is QS? Heat flux. The heat flux is constant. Meaning that any surface, we will analyze based on the condition, and it has two conditions. The first one is surface temperature constant, and the second one is heat flux constant. For surface temperature constant, this is the formula that you have to use to analyze your system ataupun your flat plate or your medium. Okay, so this is uniform temperature formula. Okay, kalau you see here, based on this slide, can you see local Nusselt number for a laminar flow over a flat plate? Can you see the symbol here, Nusselt subscript X? This means you are considering at a specific location of your flat plate. Okay, and to use this equation, okay, why I highlight this one Okay, tadi saya, just now I've told you that, okay, I've told you the Nusselt number, the formula is H L over K. This is the Nusselt number. Why I need to find Nusselt number? Because I want to know the H value. Okay, and then this Nusselt number, okay, if you see here, is also equal to this relation. Yeah, 0.332 times Reynolds number, ada certain conditions lah. So, and this will be used at certain, meaning that the local, we want to know the local H values. Okay, so to use this is the condition to be fulfilled by our system. Okay, maksud dia, if your Reynolds number is less than these values, and the Prandtl number greater than 0.6, you can use this equation. Itulah you tak tengok video saya. Nak kena cerita. Tak suka nak cerita Prandtl number lah apalah. Okay, now guys, kita mana kejap. Saya stop dia punya sharing. Guys, you all ada lagi ke? You all dah tidur semua?
Ada kata selamat kat saya.
Oh, selamat dah. Okay, good. Alhamdulillah. So, saya tak boleh jadi ni. Saya kena share juga video. Saya tak boleh nak cerita tau sebab you tak faham Prandtl numbers. Walaupun dalam video tu, saya rasa tak laju. And then, okay, satu lagi lah. Saya ada tu Muhaimin pernah bagi suggestion. Muhaimin wujud tak dalam kelas ni hari ni? Ada kan? Muhaimin, ada kan?
Saya yang cakap yang tadi tu.
Oh, tadi you yang cakap. Okay, macam soalan ni lah you ni. Okay. So okay, saya last time Muhaimin advise me. Dia kata, bukan advice lah, suggest, bukan advice. Dia kata, doktor janganlah guna lagu-lagu yang ni. Okay, betul. But sometimes saya saja macam tak nak bagi you boring. Kalau you tengok ngantuk kan. If siapa yang tak ni, you slow down. Boleh kan? Muhaimin, boleh kan? Boleh, Muhaimin dia memang okey. Sebab apa? I must share this sampai certain ni ha. I hope all of you accept my apa ni apa ni bukan my what? My technique of teaching. Sebab nak cerita tu and then ni dah lah dalam online. I don't think you want to know what if rental boring ke tak? Ke tak? You all okay je? Okay, tak maksud saya kalau saya tunjuk video tu.
Betul. Saya setuju dengan contek.
Apa dia? You
We
setuju
are
apa?
we are here to learn.
Okay. So okay, now macam lagu pula, We Are Here to Learn So okay, now boleh buat satu title tau lagu. So now first let us watch the video. Saya tahu ada beberapa orang dah tengok. And then just I nak you understand what is parental. Just focus je. Saya akan slow down the music untuk this. Sebab penat nak cerita pasal parental. Kejap mana dia? Saya share balik. Optimize for video. Include audio. Yes. Share. Sekejap ya. Cepat. Mana dia? Where's the video? Okay. Saya slowkan. Okay. Kejap Semua dengar tak?
Dengar.
Saya nak terus laju-lajukan sebab ini YouTube senang sikit saya nak control. Saya boleh pandang So this is the, kalau tengok this the objective lah of this video of the surface. Okay, ni saya nak laju. Ni saya tak perlulah sebab saya dah ajar sikit tadi. Okay, this is Nusselt number. Tadi saya dah ajar kan Nusselt number. What is Nusselt number? Local, another one is average. That one I want you to understand. Local meaning that at a specific location. Average is for the entire flat plate. First find the Nusselt number. To find the Nusselt number, we must first determine the Reynolds number. Okay, that's the tips of the process. Yeah. Reynolds number for external. So this is the formula for Reynolds number. Okay. Is the upstream velocity. Ini saya bagilah what is V, what is L, what is mu. Lagi tadi saya ajar kan. Okay, parental number. Okay, why we need to know about parental number? Can you see in Nusselt number equation just now? It has Reynolds number times parental number to the power of 1/3. Can you remember that? The equation? So now okay. This I introduce what is parental number in the Nusselt number equation tu. So itu yang saya explain. Okay, this is parental number. No need to determine. You can get the parental number from a table. Yeah. dah film temperature? Faham kan? Tadi saya dah ajar kan? Okay, now we will learn parallel flow over a flat plate. Okay, actually we have 2 or 3 types of geometry to be learnt in this subject. So the first one is flat plate. So we will how to analyze heat transfer over a flat plate. Sorry, bukan on, over a flat plate. Okay. So we call it leading edge is X equal to 0 Itu is leading edge. Kalau X equal to L, kita panggil trailing edge. I hope all of you know about that. Okay, sometimes in the question they use that term Okay, so the number we have two types. The first one is local and also another one is average. So this is average. For the entire plate. Okay, we call it as average Reynolds number to calculate Reynolds number for the entire flat plate. Okay, and then the transition, yes?
Slowkan lagu dia. Kasih berduduk.
Slowkan lagu ya?
Lagu kat YouTube tu slowkan.
Okay.
Suara doktor.
Suara saya pun slowkan.
Suara doktor yang nak dengar.
Okay, alright. Kan suara tu tak boleh slowkan suara. Okay, now kita thank you. Okay, I'll do that now. Okay. Dah slow kan lagu kan? Slow dah kan? Okay. Okay, saya macam nak berbunyi sedikit lah supaya saya tahu dia punya pace untuk saya laju ke tak laju. Okay. Sekarang ni slow ke tak suara the music?
Boleh cakap lagi.
Tadi ni kan? Ni slow tak? Tak slow?
Tahu macam biasa.
Macam tak je ya? Okey, so saya cakap saya memang dah slow gila dah tak berbunyi. Okey, tak apa sekarang kita tak bunyi. Sebab saya kalau tak ada muzik tu saya tak tahu dia bila dia nak start bergerak tau. Saya tak boleh nak agak. Saya agak. You all cuba plan. Okey, kalau plan tak dengar suara saya kan? Okey, sekarang dengar tak suara saya? Tak jelas lagi.
Ya.
Ha?
Dah dengar.
Sekejap, saya nak bagi tahu di sini. Okey, kalau can you see this? Okay, laminar flow, the condition is less than 5 times 10 to the power of 5. If you calculate the Reynolds number, the Reynolds number must be less than 5 times 10 to the power of 5. And then for the turbulent flow is beyond that. Yeah, 5 times 10 to the power of 5. I hope all of you understand. And then can you see this? Okay, it is what we call it separated by critical x. Yeah, so the distance ataupun the location is at x critical. Okay, so okay, for Nusselt number same lah. Kalau we are looking at local, local, okay, the laminar x, the Nusselt number also the local equation lah. So kalau you nampak the symbol x, subscript x, meaning that this is for local value, the h value at any position or specific distance from h. Yeah. So kalau you nampak this, okay, this one is for turbulent. Tadi for Saya nak tanya, this condition is for apa? Constant temperature. Yeah. Apa yang we are looking at now is the condition of a flat plate when the temperature is constant. Tadi I have told you we have two conditions, surface temperature constant and also heat flux constant. Okay, what you see now is temperature constant. That is why I hope all of you, if you have notes in front of you, because in this YouTube, I have included the equation number. Yeah, so that a student know, oh okay, this one from which equation. Okay, nampak ni, turbulent means Reynolds number greater than Reynolds number critical. Okay, saya ada bagi equation number like this. Okay, ini saya circle. Okay, 720 is the equation number. Yeah, so this condition, you have to fulfill this condition, baru we can use this formula. Okay, now this is the concept lah ya. I want to educate you. So the H values increases has heat record of a flat. Sorry. Tadi dia sekejap saya laju sangatlah pula. Apa tadi dia tulis? Sekejap saya nak bagi di sini. The H value, okay, can you see ada H lamina and H turbulent? And can you see H average? Saya tak boleh tunjuk sebab saya tak ada point because this is YouTube kan. The average transfer coefficient for a flat plate with combined lamina and turbulent. Can you see that the lamina H is less than convective heat transfer coefficient for a turbulent flow? Can you see this? Kan? So this I want to show you that if let's say your H, you must know, if kalau your H is smaller, you have to check whether it's turbulent or ni. Dia mesti greater turbulent rather than the H value for turbulent flow must be greater than the H value for laminar flow. Okay, the word dia. Aduh, nak ayat bukan nanti pelik So now we continue. Because we have two types of flow. So H decreases with an increase of distance x for both laminar and turbulent. We can see from the profile, right? So now for laminar flow over the entire flat plate. Tadi local Now we are looking at average. Average for the entire plate. Okay. So this is the formula to be used for laminar flow. Yeah, over the entire flat plate. Yeah, the Nusselt number equation lah sebenarnya. Okay, so di sini I explain. Okay, kalau you tengok lah ada, nampak macam saya ada bagi macam bubble like this kan. Okay, valid for a constant temperature. Nampak tertinggal perkataan temperature kan? Okay, temperature sebenarnya constant temperature. Okay, surface temperature. So this one is an option. Okay, sometimes we want to use what equation. Okay, it's an option. So but we have to check or verify the condition first. The number and also the Prandtl number is within certain values. Yeah. So now you faham tak yang ini? This is a plate with unheated starting length, meaning that at x equals 0, the heating process does not happen yet. Okay, it only started at x equal zeta. Boleh nampak tak that x equal zeta?
Nampak.
Guys,
Nampak.
Nampak
guys,
Ruta.
dengar tak suara saya?
Dengar.
Saya.
Doktor dengar suara kita tak? Muhaimin take over.
Oh yeah.
Hello, dengar tak suara saya now?
Dengar.
Dengar.
All dengar tak suara saya tadi?
Dengar.
Terdengar.
Tapi masa during tadi you ada kata no tu during when I ask no, okay Haikal, masa tu lah. Now you hear my voice lah kan? So, okay. Saya nak tanya during YouTube tadi memang you tak dengar langsung ke macam mana?
Dengar?
Dengar, waktu YouTube dengar.
Oh,
Tapi
tapi
tak
saya tak dengar you punya respon. Sebab saya ni saya stop. Saya apa? Saya slow down
You.
Patutlah lah Duhai, penat je. Okay, saya dah tak nak continue the video. I hope, bukan saya tak ada niat pun nak merajuk, tak ada satu pun rasa itu. Tetapi, I think we just now, tapi dapat tak the idea of external force convection? First, I want you to know, okay, the idea is okay, you have to determine the H value. Sebab sekarang ni, I think, kalau if possible, we have to straight away go to this back. Okay? So tadi, I hope all of you understand that we must determine the Reynolds number first, and then identify whether it is turbulent or laminar. But before that, we must also identify whether our condition is constant surface temperature or constant heat flux. Okay? For this case, kalau you nampak equation starting from 719, this is for uniform temperature ataupun constant temperature. Yeah, constant temperature applied to a apa ni, flat plate. Cakap betul tengah terbalik dah. Faham This is for this condition. Okay, either kalau now I nak padam sebab dia kacau the illustration ni. So I hope all of you know what is 719, 720, because you no need to memorize, because this is an open book test. So what I want you to do to macam buat highlight whatsoever, this is the equation that to be used during the test or exam. Yeah. So same goes for 721 and 722. Okay, 721 and 722 are for laminar average. Yeah, average. Okay, this one is for local. Kalau you nampak ada X. Okay, that's the difference between the equations. Okay, this one dah show tadi. Okay. Yang ni saya skip because this is not our scope, liquid metals. We never, I never discuss that with my students. So okay, for tadi saya kata unheated starting length, meaning that sometimes you have this kind of condition where the heating process happens after a certain or specific distance from the leading edge. So we call that as unheated starting length. Okay, if this is the case, okay, and then the heating process will only happen at X equal to zeta at this particular position. Okay, and then this is the surface temperature. Kan? So first to determine the Reynolds number, Reynolds number is the same, the formula, but for the Nusselt number, so for the turbulent, you can use equation 727, and if your flow is turbulent, you can use 728. Yeah. Saya laju-laju ni sebab I want to give you one example. So this is for heat flux. Nanti saya nak tengok ada tak example for surface. Okay, ni constant surface temperature. Can we discuss this before we stop the, I have prepared the what? Google Form attendance, the attendance using Google Form. Kejap lagi I will share with you. So this is flow of hot oil over a flat plate. Okay, so your medium is flat plate and then the length of the plate is 5 meters. And then the surface temperature is constant ataupun uniform throughout the plate at 20 degrees Celsius. And then what else? The temperature of the adjacent fluid is 60 degrees Celsius. Okay, 60 degrees Celsius. And then the velocity, that is not too far from the surface is 2 meters per second. And then, okay, can you see the total drag force? This one is macam fluid mechanics will use this information. Okay, but for us, we just focusing on the heat transfer analysis only. So first, what this question wants us to determine. So the rate of heat transfer per unit width. Okay, unit width. Width yang this one kan, per unit width. Okay. Of the entire plate, okay, of the entire plate. So if entire plate, first you must remember, first you have to determine the Reynolds number for the entire plate. And then the formula is velocity, the distance, the length of the plate and divide by nu. Okay, I have, nanti before I forgot, I have macam browse through your answer scripts, your test 1 answer scripts. I think all of you ataupun most of you get 0 for assumptions. Okay, macam saya bagi tahu, you have to specify assumptions because assumptions have marks. Yeah. I think deduct by 2, ada by 3 like that. So you must include. Most of it 0, tak dapat markah pun for the assumptions. Yeah. So although that is not requested. Okay. Siapa yang bercakap ni? Siapa? Saya dengar suara orang. Apa ni? Itulah ada meeting dia 11.30. Dengar, faham tak apa yang saya jadi you have to determine, specify the assumptions. Specify your assumptions. Okay, for this, semua orang dengar tak my voice?
Dengar, Doktor.
Okay, good. Great. Okay, now you have to determine the Reynolds number first. So, and then the velocity given, the L given, the nu. Okay, how to determine the nu? What is the liquid here? It is oil, kan? Oil. So, we have to find from a table. Okay, which table? Saya tak ingat table berapa. Table 9, I guess. Betul tak? Saturated. Oil kat mana? Table berapa dia tulis dalam contoh ni? Saya nak tengok table berapa. 13. Yeah. Okay, this table. Okay. And then, kalau you see oil, this all isobutane, okay, this one, unused. Okay, this oil. Kejap, apa aku buat macam ni? Macam ni. This one. Okay. Can you see the reference value is temperature, kan? Kalau we go back to this, the temperature is the film temperature. So that the film temperature for this case is 40. Okay, meaning that the surface plus the fluid temperature ataupun engine oil temperature tu divide by 2. So the value is 40. So we have to obtain all the density, the K value, the Prandtl number. This one is Prandtl number and then the new, okay, from this table. 40 degree mana? This is 40 degree. Saya ingat benget. Okay, 40 degrees. So the density, this is the heading of the table. The density, mana density? This is the density. Okay. And then lagi apa? The K value, maybe you need to know the K value, and then the new, I don't know why they need to know mu and new, and then also Prandtl number. You can find it in this table, yeah. So after knowing all those data, you can calculate your Reynolds number. This is your Reynolds number, the entire plate Reynolds number. It is 4.024 times 10 to the power of 4. Meaning that this is a lamina. Betul tak? Because lamina must be less than time to the power of 5. Betul tak?
Betul.
Betul.
Lambat sangat nak jawab betul.
Saya punya
Aduh.
kesel jauh dengan dia punya ni. So, dia nak berjalan tu ambil sehari juga.
Amboi, dahsyat betul tu. Dahsyat sangat. Okay. Now, if you look, okay, kita continue dekat habis dah ni. So, if you look at this, yang untuk this one, no need lah for you to focus because this is for, dia nak tahu pressure drops, drag, whatsoever lah. So, because this is not our concern, we straight away go to the heat transfer analysis. So, to determine, okay, we find out that this is lamina. So, the formula, the Nusselt number equation, related to lamina flow over a flat plate adalah this. Mana kejap saya nak pakai which this one and then this and then this. Okay. Saya tak tahu equation number berapa. If somebody can check, saya always ask my student, you must bila you write down, you boleh tak you bagi tahu equation berapa, so that sebagai grader, I want to know my student dapat this equation from where in the book lah, yeah. So this one I think 7 something tadi, saya can't remember, 720, 719 ke macam tu lah, I can't remember you better check that. So after that you find out that, oh okay, the Nusselt number is 1913. So after knowing that, you can calculate your H. Senang kan? Senang ke susah?
Boleh tahan.
Apa bertahan senang ke bertahan susah? Yang mana satu?
Antara dua tu lah.
Okay. Saya senang je kalau yang chapter ni lah. Okay, this is your H value. The unit is watt per square meter Kelvin. And then finally from there you can use this value to calculate your heat transfer rate over the plate. That is 11,000 watt. Senang kan? Senangnya saya rasa. Tak apa, I will discuss further about, but I hope all of you watch again the video. Sebab the video tu saya very try to make it as friendly as possible. Ya, macam all the term I define it, each term untuk bagi student understand. Itu my intention lah. Ya. So this another, saya just nak tunjuk je before we stop. Okay, this one can, if you see kan, katalah you tak tengok gambar ni, macam mana saya nak tutup gambar ni kan? Tak boleh nak tutup. Tak payahlah tutup, kau dah tak kan? Okay, macam ni lah, saya just guna which, this one, sorry. Okay, ini dah habis power dah ni. Don't see this. Katalah tak nak tengok. You just focus on the description of the problem. To defrost ice accumulated on the outer surface of an automobile windshield. Water is blown over the inner surface of the windshield. Yang ini sekejap saya akan tunjuk ni. Ini sebab dalam, ya. Where should I go? Okay, saya stop kejap. Kejap kan, kita nak habis dah kan. Lagi 4 minit. Tak apa, nanti saya masuk yang meeting satu lagi tu lewat. Sikit je lewat dia. Sekejap. Sekejap ya, saya laju. You tak nampak lagi kan? Tak nampak lagi kan? Sebab saya saja tak nak tunjuk lagi. Okay, flat plate. Okay. Okay, guys, you dengarkan lagi suara saya kejap Saya akan okay, thank you Siti. Sekejap sebelum. Saya ni dalam 2-3 minit je. Okay, saya tak bercakap, you tengok je Ini adalah tentang this contoh. Okay ya, itu adalah explanation untuk this example. Kalau tak faham, you can ask me in our next lecture. Okay, boleh? Let's stop.
Boleh.
Okay. Saya harap you try to understand. Mula you tengok my lecture note and then you tengok the video. Sebab the video saya explain dia punya term-term tu. Jadi you understand lah where it comes from. Okay. Sekarang saya nak share attendance Google Form and then we can stop our today's lecture. Mana sekejap nak cari pun bukan senang tau nak cari. Sekarang saya dah stop sharing, right? Okay.
Yes, doktor.
You all jangan stress tau. Just macam enjoy je live macam tu. Jangan stress. Okay? Copy link. Sekejap. Okay, saya share dekat dalam chatting. Bagi link lain lah pula. Yelah kot. Okay, cuba tengok. Saya takut saya terbagi link apa ke. Aduh, bahaya juga ni saya ni. Okay, that's all for
Attendance close,
today.
doktor.
Ya?
Attendance close.
Salah je ke? Kejap. Apa saya buat ni? Kejap. Ya ke? Kejap. 20 lah. 20 + 5. Patutlah. Saya ada yang terbaru. Kejap. Salah. Thank you. Tengok tak? Saya dah kata dah macam betul lah tu. Aduh. Kejap. Copy link. Thank you sebab you check. Bagus pun. Okay, this one betul. InsyaAllah. Okay, try this one. Boleh?
Ini boleh Doktor.
Yang ni boleh Doktor.
Okay, alright, okay. So okay guys, happy selalu. Jangan, don't think too much lah. Relax je. Like the flow, like the times goes by. Just flow, just follow the flow. Okay? We cannot control it. We just follow je. Okay? So I hope all of you still ada apa orang kata, bukan motivation. Apa dia panggil tu? Still have apa semangat apa semangat apa?
Courage, spirit.
Encourage. Okay. Mesti ada that kind of apa ni apa yang panggil feature ke criteria ke something lah embed inside you jangan don't focus on the bad things, just focus on the good things. At least you all tak duduk dalam ward tu, at least you tak berada dalam ICU tu. You just think macam tu je. Okay? Kalau you think that okay, saya good, saya tak masuk ICU pun daripada orang yang masuk ICU. Jadi macam tu you rasa okay, you always blessed with your life. Okay guys?
Okay, Doktor.
Baik Doktor.
Okay, now you can dismiss now. You can leave the ni and then we will meet again on Thursday.
Thank
Okay.
you Doktor.
Okay,
Assalamualaikum.
welcome.
Stay safe.